Hi guys, now in this video we're asked to find the missing term to make this each quadratic expression a perfect square. Okay, now if you notice we are only given two terms and we're asked to find the final term. Now based on what we have been doing so far, this should be pretty easy, and just for you to note that questions like these you may see on your end of year exams or your pre-algebra courses if you're in college. Okay, now one important thing to note when working questions like these, when you're given an algebraic expression, moreover a quadratic expression in this form, and you're asked to find the missing term to make it a perfect square, we can just note carefully, since we're dealing with a quadratic, let's just make a note of what the quadratic expression looks like. Right now, since we want to turn this into a perfect square, we are going to use the method that we have been using thus far, which is a half of b all squared must be equal to a times c. Okay, if you notice, however, in this case we are given the first term, the x squared term, and we are given the b. So we are given ax squared here and we are given bx here. However, the c is missing, so we're going to substitute our values and then solve for c. So in this case we would have, just let me change my color, we would have here a half, and b is negative 10 times negative 10 all squared. We're just substituting, and that must be equal to a times c. And if you note, I had placed the coefficient of x squared, which is a, there. So I have a times, but they didn't give us c, so c is what we're solving for. So what I'll be doing here inside the brackets, I'll be taking a half of negative 10, and a half times negative 10 will give me a negative 5, and I'm going to square that, and that is equal to 1 times c will give me c. Now negative 5 all squared is the same as negative 5 times negative 5, which will give me a positive 25, and c is equal to positive 25. So there we go, we have found the value of c. So we now have to, and just let me make a split the screen there rather. So for question 1, we have now found the value of c, so we can rewrite by saying x squared minus 10x, and this is a positive 25, plus 25 would make question 1 a perfect square. So the missing term that we had found here is 25. Now let's move on to question number 2. Now if you notice, in question number 2 it's a little bit different. They gave us the first term, which is the ax squared term, if you are matching, and if you notice, we weren't given a term in x, so the middle term is missing, but they had given us our constant c, which is 16. So again, to solve for the missing term, which is bx, that term here in the middle, I'm on question 2 now. Again, I'll go back to what I know about a quadratic expression, and we would know that a half of b all squared is equal to a times c. Now I'm taking a half. Were we given b? No, we don't know what b is. We're trying to solve for b. So I'll put back my b all square, and that must be equal to the coefficient of x squared, which is a. Here it is 1 again. Okay, so I would have a 1 in front of the k, so it's 1 times my constant c, which is 16, this 16 here. So I'm saying a half of b all squared is equal to 1 times 16, which is 16. Now this is pretty interesting. Here we have a squared term here, and that is equal to the constant 16. So to solve for b, since this side is square, I must take the square root of both sides. Okay, so I'm taking the square root of both sides. And in this case, I am more interested in the positive square. So here now, we know that the square root would cancel the square, so we're left with a half of b. A half of b is equal to the root of 16, and I'm really taking the positive root of 16. Okay, now we have a half times b. I need to transpose or make b the subject, so a half is multiplying b, so a half of b is equal to 4. Now a half is multiplying b, so since it's multiplying, to make b the subject, I must divide through by a half. Okay, and we would know that what I do to one side of my equation, I must do it to the other side of my equation. Okay, so I'm dividing both sides by a half, so a half will cancel a half, and 4 divided by a half is this 4 divided by a half is the same as saying 4 times 2. And let's look at it. This is b is equal to 4 divided by a half. These two statements, this statement here, and this statement is the same thing. This line means to divide, hence I've changed the sign to division. Now we would have already learned that when dividing fractions, it's the same as multiplying by the reciprocal. So basically b is equal to 4. I'm going to change my division to multiplication, and I'm going to flip the fraction at the back to say 4 times 2. So b is equal to 8. Okay, so b is equal to 8, and that's my answer. Okay, so the missing term that I was looking for here in part 2, let me pull it down a bit. The missing term here that I was looking for is 8. Okay, so I would now rewrite number 2 by saying k square plus, and I have gotten an 8 for my answer because the value of b is 8, so it would be 8k, and we would have our c that was given plus 16. Okay, and you can try number 3 for yourself, and later on we'll look at it. Okay, I want you to try that one for yourself to see what you would have arrived at. Okay, bye bye. Good.